Assalamualaikum warahmatullahi wabarakatuh. Hello, good morning everyone. My name is Teuku Muhammad Al-Aiyubi. I'm from Universitas Negeri Gorontalo, Department of Architecture. Today, I will briefly present to our study on thermal performance of solar reflective metal house in the tropical climate of Gorontalo, Indonesia. So the metal roof and walls are widely used, but high thermal conductivity cause indoor temperature to rise to until 6 degrees compared to non-metal material. Reflective paint or cool roof offer an effective passive solution by reflecting solar radiation and reducing roof and wall surface temperature. Previous studies show reflective coating can lower surface temperature by up to 6.6 degrees Celsius and indoor temperature by 9 until 12 degrees Celsius, improving thermal comfort without extra energy use. Research in Gorontalo remain limited, especially full before-after thermal assessment of the metal house. This study evaluates the thermal performance and the effectiveness of reflective coating for affordable tropical housing. And then a method. This study was conducted at the BeCool CSR project house in Dutuhe Village, Bone Bolango Regency, Gorontalo. This is the picture before and after painting. And then the study employed directly measurement approach conducted in two phases, before and after application and reflective paint to building surface. Data collection utilized an Elitech record surface and that build temperature and a thermo-hygrometer to measure indoor and outdoor air temperature and humidity. Our instrument well position is well 160 centimeter above the floor as well on the roof surface. Additional that build temperature measurement will record outside the building. So the result and discussion, the surface temperatures increase significantly between 12 until 15 p.m. With the roof being hotel element point by the south and east. Effective paint effectively reduct temperature across all building element with the greatest reduction on the roof and the east wall. While walls with lower solar exposure, north and west show only the minor reduction, indicated that effectiveness of strongly influenced by orientation. Overall, reflective paint is an effective passive strategy for reducing heat accumulation in building tropical climate. And then briefly, paint significantly reduce heat absorption on building surface, resulting in the much smaller increase indoor temperature compared to sharp rise of outdoor temperature, which can exceed 15 degrees Celsius. Indoor temperature remains stable despite large functional outdoor, showing that reflective paint effectively minimize suddenly thermal change. A, a substantial temperature difference of 16 until 17 degrees Celsius between indoor and outdoor conditions during peak heat hour confirm the strong role of reflective paint in limited heat transfer into the building. Reflective paint does not cool the room directly but reduce solar radiation and heat absorption on the surface, thereby decrease heat again and improving indoor thermal comfort under extreme outdoor temperature. So the conclusion is reflective paint effectively improve thermal performance by reducing surface heat absorption, and keep indoor temperature more stable. Despite extremely outdoor conditions with temperature above 50 degrees Celsius in the department increase more slowly with differences reaching 16 until 17 during peak heat hour. Stable indoor temperature and humidity show that effective can reduce heat transfer and mitigates sudden thermal functional. Future study should include a long-term monitor and tests on different color, material, and weather conditions to assess durability and effectiveness in tropical climate. So that's all my presentation. Thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh.